Hello, guys. Welcome back to Maths African Motives, still on our mathematics revisions. In this platform, we shall be focusing on partial fractions, which is how to actually convert a certain fraction into partial fractions. So this is actually the introduction part that we are going to have in this class. So let's say we are given a consideration from our algebraic addition. So let's just say from algebraic addition, I want you to see something in this case. All right. We know that if we are given our addition, it can be addition or it can be subtraction in this case. All right. So let's say we've got two fractions that you are algebraically adding or subtracting. Let's just take an example. For x, we've got 1 over x minus 2 in this case, plus 3 everything over x plus 1 like this. This part here, you'll be asked to simplify to a single fraction, that is to add. So we know that we are supposed to have our LCM of it. So I'm just going to show you where we are now having the introduction of the partial fractions in this case. So remember that your LCM, that's the two denominators, x minus 2 and x plus 1 in this case. So if we are to simplify, we are going to divide x minus 2x plus 1, our LCM, divide by x minus 2, meaning to say we are going to remain with x plus 1, which is multiplied to this 1 in this case. All right, we've got a plus, in this case 3, then x plus 1 and x plus 1, this will cancel if you divide, meaning to say we are going to remain with x minus 2. So expanding our brackets, 1 is going to multiply everything in this bracket, which is going to be x plus 1. 3 times x, that is going to be 3x. 3 times negative 2, which is negative 6. Everything, in this case, is going to be over the denominators, which is our LCM of x minus 2 into x plus 1. So collecting like terms, we've got x in this case, which is same as 1x. So if we are going to add in this case, this is going to be 1 plus 3, which is 4x. Then we've got 1 minus 6, which is negative 5, everything over x minus 2 into x plus 1. So here the question is, this fraction that we see here that we have simplified into, it's a single fraction that is the one that we have. So these are typical questions where you are asked to leave your answer as a single fraction. So the partial fraction now part, this of partial fraction is whereby we are now expanding this single fraction that we are given here into the two fractions that was before. So changing this fraction into this format, this is the partial fraction part. We are having a single fraction that we are going to convert to fractions that are being added or subtracted, whether they are going to be 3, depending with the number of brackets that you have in the denominator. So it was supposed to be a reverse calculation, but there is another way that you're going to have. So as we can see, the number of denominators that we have, if we have got two values, in the denominator, the numbers that we have or the terms or the brackets in the denominator, if they are 2, it means we have got two fractions separated. Meaning to say, if they were 3, we're going to have 3 fractions separated. So it follows that in a linear expansion, whereby you are given linear factors, you're supposed to know this consideration that if we are given a linear factors, let's say your denominator is having linear factors in this case. All right. So on a condition of linear factors, let's give an example of an expression given as f of x over the brackets. Maybe we can say we've got x plus a, we have got x minus b, we have got x plus c, depending with what you're given on the denominator in this case. This can be given as or is equivalent to now into partial fractions. We are now expanding this to partial fractions. So you ask yourself, how many terms are in the denominator? We've got 3 terms. So for linear factors, you're going to have a over the first bracket, which is x plus a, plus the one for x minus b. So you're going to have b over x minus b, plus the one for x plus c, which is c over x plus c, where a, b, c are the constants to be found, which means we have to calculate these values for a, b, and c. So you have to take note that in order for you to apply this, the denominator must factorize. So we have to make sure that your denominator in this case factorizes. All right. If your denominator factorizes, then we must factorize our denominator first, and we can express into partial fractions. And also, it must be a proper fraction for you to apply this. We are going to talk about a consideration of improper fractions. How do you work out improper fractions? So this is the first consideration that we have, whereby we are dealing with linear factors. What about if we are dealing with the repeated linear factors? What are the repeated linear factors? So I'm going to pose examples later on. All right, so we've got repeated linear factors. This is a consideration now where we are given our f of x in the format of, let's say we've got f of x into x plus a to the exponent of 3, or to the exponent of n, whatever exponent that you're given. So this can be given or can be expressed into partial fractions as a over x plus a. So you're going to start from the bracket of x plus a up to the exponent of 3. So you start from the exponent of 1, you move on b over x plus a to the exponent of 2 up to the exponent that you are given here. So it is going to be c over x plus a to the exponent of 3. So you start from 1, 2, 3 up to the, if it was 4, we move on plus d over x plus a to the exponent of 4, like that. These are repeated linear factors. So that's how you expand under partial fractions, which can be a vice versa. You can even start with the 3, 2 up to 1. You can start with this fraction up to 1. All right. So we have the last part that we are going to consider under our partial fractions, which is a condition whereby you are dealing with quadratic factors. All right. So that's quadratic factors. Remember, I said the denominator must factorize in order for you to express into partial fractions for linear factors. It's because the denominator factorizes. But if we have got a condition where the denominator, where you cannot even factorize the denominator, there are expressions like that. Let's take for an example of those terms. Let's say that's a quadratic expression that we can't factorize. Okay, so let's say we have got ax. In this case, we are going to write our normal quadratic expression ax squared plus bx plus c, where this quadratic expression that we have here cannot be factorized, cannot be factorized. If you can't factorize this quadratic factor, this quadratic expression that is in the denominator, therefore, we are going to write this as equivalent to ax plus b. Take note here what we are saying, ax plus b. This is what you're going to expand as. All right, everything over ax squared plus bx plus c, which is that quadratic part that you have. This is a consideration. We've got quadratic expressions such as, I want you to check this one. Can we factorize x squared plus 2, or maybe x squared plus 3, or maybe x squared plus 9, whatever that you're given? We can't factorize these typical expressions. So these are the ones that we refer as quadratic factors, the ones that we can factorize. So on a condition like this, you expand your fraction into this typical part that you are I'm presenting here. All right, so let us have these into separate examples, starting with the linear factors repeated, linear, and so forth. All right, so we saw that under linear factors, this is what we have, f of x being equivalent to a over x plus a, b over x minus b, plus c over x plus c. All right, so let's say we are asked to resolve into partial fractions the following. Let's just have a question, resolve. All right, so the question can be like this. Okay, so that's resolve 11 minus 3x. So we are given 11 minus 3x, everything over x squared plus 2x minus 3 into partial fraction. All right. So that is what we are given in this case, into partial fractions. All right. So take note of your denominator in this case. The first thing is to check, is it a proper fraction? How do you check that it's a proper fraction? A proper fraction is the one that you are given with, let's say we have got f of x over gx like this. If it is a proper fraction, when we are saying this is a proper fraction, your numerator in this case is supposed to have a lesser degree. All right, so this is supposed to have a lesser degree than this one in the denominator. So it's supposed to have lesser degree than the denominator. All right. So what are we trying to say in this case? The exponent, we are supposed to have, if this is x squared plus 3, we are supposed to have a bigger exponent, x cubed plus maybe 2x squared plus 4 like that. We can check that in the numerator, the highest exponent that we have is 2. In the denominator is 3. So it's a proper fraction. We've got a lesser exponent in the numerator compared to the denominator. But if I am given x to the exponent of 3, everything over x squared plus 2x plus 1, it's now an improper fraction that we are given in this case. So we are now having an improper fraction. Why are we saying so, that this is an improper fraction? Because of the degree that we have in the numerator. It's now bigger than the one in the denominator. We are having 3, we are having 2. So we shall talk about this. How do we work out improper fractions? All right. So that's how you check, is it an improper or it's a proper fraction? So now if we can check here, this is a proper fraction. Why? This is x to the exponent of 1. This is to the exponent of 2. So we've got a lesser exponent in the numerator than the denominator. So it's a proper fraction. So we can resolve this into partial fractions. So the next thing that you are supposed to do after checking that it's a proper fraction or not, it is to check, can you factorize the denominator? Remember what I said on linear factors, that the denominator here must factorize. If the denominator is not factored, then it's a quadratic. So in this case, we have to check, is this denominator actually, can we factorize our denominator in this case? So we're given x squared plus 2x minus 3, whereby the highest, the coefficient of x in this case is a 1. So we can have 2 brackets. That's x here, x. Remember, we focus with the constant -3. Factors of -3, when we add, we obtain -2. That's factors of -3. We've got a 3 and -1. 3 times -1, that's -3. 3 plus -1, that's a +2. So we have got 3 and -1. So that's +3 minus 1, which means we can factorize this denominator into 2 brackets, x plus 3, x minus 1, or x minus 1, x plus 3, depending with the way that you want to have it. So now we can rewrite this whole part of our question as 11 minus 3x, everything over our denominator, which is now into a factorized part, which is x plus 3 into x minus 1. So this is what we have in factorized manner. So remember that if you can have 2 brackets like this, that's a linear expression, that linear factors. So we can have this as a over the first bracket, that's x plus 3. Plus, we have used A, you move on to B, C, D, E, F, and so on. So we move on to B. So this is B over the second factor, which is x minus 1. So this is an equation that we have solved that you are going to solve for a and b, because we are saying this can be written as a over x plus 3 plus b over x minus 3. So these two, they are equal. So if they are equal, therefore, let us solve for a and b. How are we going to do this? All right. In a normal consideration, we're supposed to actually divide, like to have this x plus 3, x minus 1, but do not waste your time like that. Just equate 11 minus 3x in this case. So this is going to be 11 minus 3x is equal to. So you work with a. So what you're going to do, this is the LCM because you separated these two brackets from these two. So we're going to have a into, you divide LCM divide to x plus 3. So x plus 3 and x plus 3 will cancel. These two, they will cancel, which means you remain with x minus 1. So this x minus 1 is going to multiply to a. We move on to this bracket with this plus this part of b. So it's going to be b. We divide again our LCM to x minus 1. So x minus 1 will cancel. We remain with x plus 3. So you do not cancel to say, I'm going to cancel, so there's nothing. No, you assume that this will cancel, so you remain with x plus 3 like that. So these two, remember, they are equal. It's an equation that we are having, and we are saying these two, they are equal. So how can you solve for a and b? For linear factors, it's an advantage. The advantage that you have is that you can let each bracket to be equal to 0. Remember that if this is equal to 0, I just want you to see something. If this is equal to 0, it means we are just left with b. So if you can just let this be equal to 0, it means this whole part is no longer there because you are going to multiply 0 by this term. So a times 0, which means we no longer have this. We are just remaining with the part of b and this part. So you can find the value for b. So that's how you are going to solve for it, to find b, to find a. So which means for us to have this as a 0, we are just going to equate this to 0. So meaning to say, I can just say from this bracket of x minus 1. So from x minus 1. So I'm working with this bracket, okay? So I can just equate this x minus 1 be equal to 0, which means x is going to be 1. If I transpose, x is going to be 1. Meaning to say, for this bracket to be equal to 0, our x is supposed to be equivalent to 1. So that means when x is equal to 1, so when x is equivalent to 1, let's see what is going to happen, which means you are going to substitute now the value of x that you are given, which is a 1. So when x is equal to 1, you substitute here. That is going to be 11 minus 3 times 1, which is equal. The moment we substitute 1, it's now 1 minus 1, which is a 0. So which means we no longer have this part because 0 times a, that's a 0. We move on when x is equivalent to 1 here. This is going to be 1 plus 3 times b, which is 4. So you can simplify what is on the left-hand side, and you simplify also what is on the right-hand side in this case. All right. So in this case, this is going to give us 8. So 8 is equivalent to 1 plus 3, which is 4b. So we can divide by 4 in this case, meaning to say our b is going to be a 2. 8 divided by 4, that's 2. So b is equal to 2. All right. So that is how we can find our values. So in order for us now to find a, we are going to concentrate on the bracket of b. So we're just going to let x plus 3 to be equal to 0. So if x plus 3 is equal to 0, meaning to say x is going to be equivalent to minus 3. So what does it mean? You are going to substitute x when it is equal to minus 3. So when x is equivalent to minus 3, that means on the left-hand side, this is going to be 11 minus 3 times the value of x, which is minus 3, which is equal to the value of x here on a. We substitute minus 3. So this is going to be minus 3 minus 1 times a, which is going to be minus 4. So here we've got minus 3 plus 3. If we substitute minus 3, that's a 0. So that means we have got nothing. That is going to left 0 times b, that's a 0. So let's simplify 11 minus minus, or if you simplify properly, that will be a 20 is equal to minus 4a divided by negative 4 by negative 4. So a is going to be equivalent to negative 5. So we have the values of a and we have the value of a and also the value of b. So what are we going to do with these values that we have? We are going to substitute into the format that we are given here. Remember, we said 11 minus 3x over this is equivalent to a over x plus 3 plus b over, so meaning to say we can substitute now to say here our a, we said our a here, that's a negative 5, our b, that's a 2. So this whole part is going to be equivalent to our a, which is a negative 5, so it is going to be minus 5 over x plus 3. Our b, that's a 2, so it is going to be plus 2 over x minus 1. Or you can even write from this one, 2 over x minus 1 minus 5 over x plus 3. So you have converted this, or you have resolved this into partial fractions. So what is important is you are changing a single fraction to two fractions that you're given. So what matters is you check your denominators. Is it possible for you to factorize the denominator? If possible, that is you are having 2 or 3, whatever the number of brackets that you're going to have. Those are the linear factors that you are having. All right. So that was our first example. We are going to check another part in this case. Let us check a condition whereby we are having now repeated. So like I said, check first, is it possible for you to factorize? If not, then it means it's a quadratic. That part that you are given, it's a quadratic. If it is not factorizing, so maybe we can just check 1 or 2 on quadratic. All right. Let's just say this one, express again into partial fractions, 7x squared plus 5x plus 13. So this is what you're given, everything over x squared plus 2 into x plus 1. All right, so this is what we have. So checking first, is it a proper fraction or not? How are we going to see if it is a factorized? We check the number of brackets. Then also here, if you are to expand, remember when you expand, you're going to multiply first bracket to the other one. So if you multiply x squared to x, in these two, you are going to obtain x to the exponent of 3. So that means we are having the highest exponent in the denominator. So it's a proper fraction because compared to 2, this is the highest exponent. So that means we are having a proper fraction in this case. So if it is a proper fraction, that means we have to factorize wherever it's possible for us to factorize, of which here, if we are to check, we can't factorize x squared plus 2. So that means this is a quadratic factor. So we are having a quadratic factor. Then x minus 1, that's a linear factor. The highest exponent is 1, so that's a linear. So we have got a combination of a linear and a quadratic in this case. So remember how you expand a quadratic, how you expand a linear. So that means this whole part is going to be equivalent 7x squared plus 5x plus 13, everything over x squared plus 2 into x plus 1. So resolved into partial fraction for a quadratic, remember we said it gives us ax plus b, ax plus b. So if you are having it as the first part, then you express it as ax, and of which we have it as the first term. So this is going to be ax plus b over our quadratic factor, which is x squared plus 2. All right, we move on to the linear factor, which is x plus 1. So this one is just going to be plus a constant c over x plus 1. We have used a, b, we are now at c. So that's how you expand, of which someone could have started with a linear factor, which means it was going to be a over x plus 1 as a linear factor. We move on to the quadratic factor, which means we are now, we have used a. So we're going to move on to b. So it is going to be bx plus c over the quadratic factor of x squared plus 2. So this is another way that we could have expanded our partial fraction in this case. All right, anyways, let's simplify so that we can calculate the values of a, b, and c. So these are the constants that we have. We have got a, we've got b, we've got c in this case. So how are we going to have this value of b? How are we going to have this value of c from this information? Remember, I said we are going to equate the numerator now. So we are dealing with the numerator to say the 7x squared plus 5x plus 13 is equivalent to, you divide. So you're going to take the numerator as it is, which is ax plus b. So if you are to divide your LCM divided to x squared plus 2, you see these two will cancel, which means we remain with x plus 1. All right, we move on to the other fraction, which is plus c, our constant, into, if we divide x plus 1 and x plus 1, this will cancel, which means we remain with x squared plus 2. So this is going to be x squared plus 2, like that. All right, so this is what we have. So remember what we said, in order for you to determine these values, we can let, especially a linear factor, we can deal with a linear factor. In this case, there is a linear factor here, so we can play around the linear factor, which is here at x plus 1. We saw that it's easier to work with a linear factor because we can make this to be equal to 0. So if x plus 1 is equal to 0, that means x at that moment will be equal to minus 1 by solving for x. So that means in this case, when x is equal to minus 1, I am eliminating this whole part, because this is going to give us a 0. Then 0 times this whole part, that's a 0, which means we have eliminated this whole part. So let's substitute. When x is -1, we substitute -1, -1 in this case. So this is a condition that is easier to work with. We start with what is easier in this case. So this is going to be 7 into, all right, let me just bring back this one. So we said when x is -1, that is going to be 7 into -1 squared plus 5 into -1 plus 13 is equal to, now we say this whole part is a 0, so we're going to substitute -1 here. So by just looking here, this is going to be -1 squared plus 2, of which -1 squared, that's 1 plus 2, which is 3. So we are going to obtain 3c in this case. So this whole part is going to give us 3 times c, which is 3c. So simplifying our left-hand side, we are going to obtain 15. So 15 is equivalent to 3c. Divide by 3. By 3, we have got the value for c in this case. So what is the value for c? C is equivalent to 5. Okay, now with the value of c, which is equal to 5, we can substitute back into, so we can have this because we don't have a b, sorry. So which means we have to calculate a and b. But now it's very, very difficult for us to work with this. I want you to see something, because we're supposed to let this bracket to be equal so that we can say x squared plus 2 is equal. But look now, if we are to let this to be equal, so it's going to be x squared is equal to -2, and we can't determine the square root of this because we are now having a complex solution in this case, where we are now talking about I or j, which cannot help us to have the value. So which means we are limited on a quadratic factor to determine the value of x. So what are we going to do? All right, we are going to have back our normal expression as it was from here. We expand everything so that we can equate the coefficients. This can help us to calculate the value of A, the value of B. So what am I trying to say? We are going to expand this whole part here. I just hope, okay, let me just remove this part since we have calculated. Let me just shift it a little bit. I want to calculate these values here. All right, so I'm just going to calculate it here so that we can understand. So like we saw that it's impossible for us to equate to 0 and actually calculate for x. So this time you are going to expand and equate the coefficients. the equate corresponding coefficients. Coefficients. All right, so this is what you're going to have in this case. So we expand, that means in this case, we are going to remain with the left-hand side as it is 7x squared plus 5x plus 13 is equal to, let's expand and see, that's here, ax squared is going to, ax is going to multiply x, it is going to multiply 1, after b is going to multiply x and b is going to multiply, remember your expansion, guys, that ordinary expansion. So ax times x, that is going to be ax squared, ax times 1, that is going to be ax, b times x, which is going to be bx, b times 1, which is going to be a plus b. All right, we move on to the other term here. We've got just a c, so the c is going to expand everything in this bracket. That's plus cx squared, c times 2, which is going to be 2c. So equating coefficients or corresponding coefficients, what am I trying to say? We are saying in this case, for a term of x squared in this case, there is a coefficient which is affecting ax squared. Also on the right-hand side, we have got also x squared being affected by certain terms. So we can take that as an advantage. So in this case, working with coefficients for x squared, meaning to say we are going on the left-hand side, we just have this 7 equal to what we have on the right-hand side. So we have got the first x squared under a, which is the coefficient, the other x squared under c. So it is going to be a plus c, it's a positive. So we have formulated an equation. So we check from what we have done before. Have we calculated any of these values, a or c? So we have to check. All right. On our calculation before, remember, we calculated c and we said our c is equivalent to 5. So if c is equivalent to 5, therefore we can substitute the c that we have, which is equal to 5, into this equation that we have formulated. Our c is equal to 5. So that means we can have the value of a, that's 7 minus 5 is equal to a. So therefore, our a is equal to 7 minus 5, which is equivalent to 2. So we have the value of a, which is 2 in this case. This was from equating the coefficients of x squared. You move on to another consideration. In this case, we can move on to the coefficient of x. We are talking about x in this case. We've got x here, we've got x here, we've got x here. So this time we are going to equate the coefficient of x. So equating the coefficient of x, we said on the left-hand side, we've got a plus 5. So 5 is equal to the right-hand side. We have got a plus b. In this case, the coefficient of x is a plus b. So that's what we have. So we can calculate the value of b. Since a is equal to 2, that means in place of a, we've got 2. So transpose to the other side of the equation. This is going to be 5 minus 2, which is equivalent to b. So our b is equivalent to 3. So we have the values of a, b, and c in this case. Our a, which is 2, our b, which is 3, and our c, which is equivalent to 5 in this case. So remembering also what we had before as our format. Remember the whole of f of x that we had before, we said this was supposed to be written as, if you still remember, that first part when we expanded. So I'm just going to refer to this as f of x. Our f of x in this case, we said it can be expanded into ax plus b over x squared plus 2 plus c over x plus 1. If you still remember that first part that we expanded 7x squared and so forth and so forth. So what does it mean? This f of x is the whole expression that we had before, which is our 7x squared. So it means 7x squared plus 5x plus 13, the whole expression, which was over x squared plus 2 into x plus 1. That was the expression that we're given previously, that we expanded in this case that we got from this part here. All right, remember on this part. So now we are just going to substitute our A, our B, and our C on our final answer. So that's what I'm trying to say in this case. All right, so let's substitute our A. We got a 2. Our B, all right, so our A in this case is a 2. So this is equivalent to A, which is 2. So that's 2x. AX, 2x, plus B, our B in this case, that's a 3. So it is going to be 2x plus 3. So you've got 2x plus 3, everything over, so we are going to divide here over x squared plus 2. All right, plus the constant c over x plus 1. Our c is a positive, which is 5, so it is going to be plus 5, everything over x plus 1 like this. So we have converted this into two fractions which are separate. So that's resolving into partial fractions in this case. So these are the major part that we are going to be dealing with whenever you're dealing with partial fractions. Are you having linear factors? Are you having quadratic factors? Are you having repeated linear factors? So for repeated linear factors, that's where we said we are having two brackets of the same. All right, so in this case, I'm just going to show you just one or two, just one. Okay, let's see for repeated linear. So I just hope we had for linear, we had for the quadratic. So now let's check for the repeated linear in this case, how they can ask these typical questions in this case. All right, so let me just remove this part. All right. Okay, so I just hope this can work for us, everything, guys. I just hope. All right, so in this case, what we will be given is a consideration where you are given to resolve again into partial fractions. 2x plus 3, everything over x minus 2 squared. So still into partial fraction. All right, so we have x minus 2 squared. We mean these are two brackets of the same. So that's a repeated linear. So what does it mean? Remember, we said for a linear, we are going to express from the first exponent, which is 1, up to 2. So this is going to be equivalent to a over x minus 2 plus the second one, where we are now having b over x minus 2 squared. So this was 1, this is now a 2. So what does it mean? We can actually simplify by expressing or equating our numerators, because we have here our 2x plus 3, which can be equated to these numerators to formulate an equation. So that means 2x plus 3 is equivalent to, we have got our first term, that's a into, so if you divide, this is x minus 2 divided by this, so you're dividing this x minus 2 squared divided by x minus 2. So what does it mean? We have got something of this nature. That's x minus 2 squared divided to x minus 2. So there are two of them. So once you divide, you're going to cancel one. We remain with x minus 2. So this is going to be a into x minus 2 plus b. This x minus 2 squared, x minus 2 squared will cancel. So which means you just remain with a plus b like this. So that's it. We can still, it's a linear, so it's the advantage. We can equate this bracket to 0 just like the previous part, so that we can solve for b. So equating this to 0, that means if x minus 2 is equal to 0, x is going to be equal to 2. So when this x is equal to 2, what is going to happen? That is the consideration now. So we can say when x is equal to 2. So when x is equal to 2, we've got 2 here, we've got 2 here. That means this is going to give us 2 by 2, which is a 4 plus 3 in this case, which is going to give us a 7. So 7 is equivalent. That's here as 0. So we are going to remain with b. So that means b is equal to 7. There's nothing that we can do on b. So either you can let x to be equal to 0, or you can expand just like what we saw previously. This can help us also to calculate for x. So expand and equate coefficients. So if we are to expand, in this case, the left-hand side is going to remain as it is. 2x plus 3 is equal to a times x. That is going to be ax a times -2. That's -2a plus b. So in this case, we can check here by comparing the coefficients, dealing with the coefficient of x. We have got the coefficient of x on the left-hand side, which is a 2, is equal to the coefficient of x in this case, which is a. So that means a is equal to 2, just like that. We can have a value, the value of a. So that means our a is equal to 2, our b is equal to 7. So we can substitute back here into this format that we are given. So we had this as x is a over x minus 2. So that means at the end, therefore, the whole function that we're given before of 2x plus 3 over the bracket of x minus 2 squared is going to be a over x minus 2, which is our a is 2. So that's 2 over x minus 2 plus b, which is 7 over x minus 2 squared. So that is what you're going to have now as your final answer for having this into partial fractions. So these are the typical questions resolving or involving partial fractions from linear factors, quadratic factors, repeated linear factors. So that's how they can ask these typical questions. So you have to be very, very careful how you attempt your questions. How do you expand each, or how do you resolve each into partial fractions? Because everything that you're going to be having is by the laws or the rules of and that is under partial fractions. So you have to work on more questions and revision. But for now, that's what we had on our introduction. So we've got a lot of questions that we have. Let us continue to revise from our textbooks, past exam papers, and so forth, that can actually help us a lot in preparation of any exam that is ahead of time. So that is for now from Maths on African Motives. Till we meet again.